This is a follow-up to a short sequence of videos I've made about how to get data from closed Excel workbooks. So far we've covered how to get data from a single Excel file with a single worksheet in it. Then we expanded on that and looked at how to get data from multiple closed Excel files. And in the last video we looked at how to get data from a single Excel workbook that contains multiple worksheets. So for my next trick, we're going to put all of that together and look at how we can get data from multiple worksheets in multiple workbooks without opening up a single file. Well, apart from the one that we'll write our code in, of course. So to get started, I've got an almost blank workbook. It's got some column headings that indicate what data we're going to get from our different workbooks. And the workbooks we're going to get our data from each look a little bit like this. So here's one of the example files. It's got movies from the year 2011, and the films that we're going to extract are spread across multiple different worksheets, one for each month in which the films were released. And we've got a folder containing multiple files sitting in the same directory as the workbook we're going to add our code to. So in the My Files folder, we've got 6 different years worth of films to get. So I'll just close down the Movies 2011 workbook. I've saved the main workbook as a macro-enabled file already. So at this point we can head into the Visual Basic Editor and we can insert a new module into the project and then create a subroutine called something like Get All Movies. The first thing we'll do in the subroutine is write some code to loop through the collection of files in the My Files folder and retrieve the name of each workbook. To do that, I'm going to use a couple of variables to help. So the first one's going to store the path to the My Files folder. So I'll call this one My Files Path as string. And the second variable is going to hold the name of each movie workbook. So I'll call this one Movie File Name. And that will also be a string. Just to help, I'm going to concatenate the path to the My Files folder first and store that in My Files Path. So I'll say My Files Path equals this workbook.path and concatenate that with a backslash and the name of the My Files folder and another backslash. Then I would like to try to get the name of the first XLSX file in that folder. And to do that, I'm going to use the dir or directory function and store the result in the movie file name variable. So let's say movie file name equals dir and then open up some round brackets. I'm going to reference the My Files Path variable first to return the path to the My Files folder, and then concatenate to that the search string for XLSX files. So in some double quotes, I'm going to type in an asterisk, which is a wildcard character, so any file name, followed by .xlsx, so any file in that folder with an XLSX extension. I can then close the double quotes and close the round brackets, and that's going to return the name of the first file, if there is one in that folder, with that extension. Then I'd simply like to carry on trying to find files with that search pattern until I run out of files in the folder. So I can do that by saying do until movie file name equals an empty string. If the dir function doesn't return the name of a file, then it will simply return an empty string, so my loop will stop at that point. I'll provide a couple of blank lines then and write the closing point of the loop, which will be the word loop. And then inside the loop, I can debug.print the movie file name and then try to get the next file. And I can do that by saying movie file name equals dir without passing values to any of the parameters of that function. So having done that, I'm just going to run the subroutine and we should find a list of all of the movie files from the My Files folder get printed out to the immediate window. Next, I'd like to take the name of each file that we found and use that to create a connection to the workbook. And to do that, we're going to use the Microsoft ActiveX Data Objects library. So let's set a reference to that library first so that we get some help from the IntelliSense. If we head up to the Tools menu and choose References, we can then scroll through the list to find the Microsoft ActiveX Data Objects libraries. You should have several different versions installed. Just go with whichever the latest version you have available is. In my case, that's the 6.1 library. Having checked the box next to that, I can click OK. And now I can declare a variable to hold a reference to the connection object that we'll create. So let's say dim cn as adodb.connection. I'd like to create a new instance of the connection class before we begin this loop. So let's say set cn equals new adodb.connection. And then inside the loop, we can create or set the connection string property of the connection object to point to each file in turn. So just after I've debug.printed the movie file name, I'm going to say cn.connectionString equals double quotes, double quotes. Now I'm not going to write out my connection string from scratch. I very, very rarely do. What I tend to do, and you'll know this if you've watched the previous few videos in this sequence, is use the connectionstrings.com website for all your connection string needs. You get an idea as to how many different data source types you can connect to with ActiveX Data Objects here. We're going to stick to Excel, of course, so I'll click the link for Excel. And then from the list at the top, I'll choose the relevant provider or driver. In this case, it's the Microsoft ACE OLADB. So I can click on that and then scroll through the list to find the particular version of Excel I want to get my connection string for. When I find the Excel 2007 connection strings, nothing much has changed from that point. If I go through Excel 2010 and Excel 2013, the last time there was a major change here was in Excel 2007 when the XLSX file extension was released. So I'm going to copy this connection string here for the XLSX files. Do be slightly careful about the type of file you're connecting to. The connection string is subtly different if you're connecting to binary workbooks or macro-enabled workbooks, so make sure you get the correct one for the file type you're connecting to. I can then copy that to the clipboard, head back to the Visual Basic Editor, and then paste that string inside those double quotes. I've got a bit of tidying up to do, of course, as usual. I don't want that written out on one single continuous line. Let's split it across multiple lines using the space underscore continuation character. So I'll take the entire string down to its own separate line first, and then find the first semicolon in the connection string. So I've basically at the end of the first property set in the connection string, which is provider. I can then close the double quotes after the semicolon and then concatenate that with a space underscore and then take the data source down to the next line and open up some more double quotes. I'll just find the end of the data source property there and close some more double quotes and then concatenate that with a space underscore and take extended properties to the next line. And then a couple of extra little bits of tidying up to do. If I click away from that line, the syntax checker kicks in and shows me I've got a syntax error somewhere in that block of code. The syntax error comes from this nested string inside the connection string. So the extended properties property is set using a string. The problem is that I'm using double quote characters to delimit that string, and Visual Basic or VBA already uses double quotes to delimit strings. So what I have to do is either double up my double quotes, which I think looks a little bit odd, but it works, or you can replace the double quotes with single quotes instead, which I think looks a little bit neater. And that will now work. So what else do we need to do? We need to modify the data source, don't we? So let's get rid of the C:\my folder all the way down to the XLSX. And I'm just going to backspace that to get rid of it all. Then I'm going to close some double quotes after the data source equals section and then concatenate that with some more text and then concatenate that with the semicolon character before moving to the next line. So it's what we put inside here that's important. I need to construct a complete path to the file. So I'm going to concatenate my file's path with movie file name. So let's insert my file's path, ampersand, movie file name, and that will construct the complete path to each Excel workbook. Once I've done that, just to test that things are going to work, before we move on to the next movie file name, let's give myself a few blank lines so I can insert some more code later. To check it's going to work, I'd just like to attempt to open up the connection. So I'm going to say cn.open, and then before we move on to the next movie file name, I'm going to say cn.close. And of course, we'll put all of our exciting, interesting, useful code in between these two lines. To check that it's going to work, I'm going to use the F8 key to begin stepping through the procedure. So carry on pressing F8 until we reach the line that says cn.open. Now, as long as nothing happens when I execute this instruction, things are working properly. If I press F8, nothing happens apparently, although we have created our connection object and opened it up, so we can investigate some of the properties of that connection object in the locals window if you like. But all I'm going to do is hit the F8 key to close that connection down again, and then move on to the next movie file name. So at this point, I'm just going to hit the play button or press the F5 key to continue running the subroutine, and that will loop through all of the files, opening and closing the connection to each one. Next, I'd like to return a list of the worksheets in each of the workbooks that we've connected to. And to do that, I can use a method of the connection object. I can say cn.openSchema. The schema is something which gives you information about the structure of the data source you've connected to. So if I open up some round brackets after open schema, you can see there's a list of preset units of information I can return. So I can return information about the columns, for example, and various other aspects of the data source. What I'm interested in is returning information about the list of tables. So in ActiveX Data Objects, when you connect to an Excel file, the worksheets are treated as tables in a database. So I'm going to go with AD Schema Tables. Now you can hopefully see in the tooltip that's appeared here that the result of the openSchema method is a Recordset object. So I'm going to declare a variable that can capture the result of this openSchema method. So let's head back up to the top of the subroutine and declare a new variable. I'm going to call this one rssheets as adodb.recordset. I can then say, in front of the cn.openSchema statement, I can say set rssheets equals cn.openSchema AD schema tables. Finally, I'd just like to write out the contents of that record set as quickly as I can into a cell on the worksheet that I currently have available. So I'll just write them out starting from cell A3. So let's say sheet 1, I'll reference it using its code name just for convenience. I'll say sheet 1 dot range A3 dot copy from record set. A dedicated method. If you could think of a better name for a method that copies information from a record set, I'd love to hear it. And all we have to do here then is pass in the reference to the record set containing the data we want to write out. So that's rssheets. Now I don't want to do this for every single workbook that we're connecting to. They'll just overwrite each other based on the way that I'm writing out this information into the worksheet. I just want to write out the contents of one single sheet at a time, so I'm going to set a quick breakpoint on the loop line so that it will stop after the first iteration of the loop, and then I'll see the results. So I'm going to hit the run button here, and we end up paused on the loop line, and then I'm just going to stop running the subroutine at that point, have a quick look in the Excel worksheet, and there we go. I've got a list of all the tables in the first workbook that I've encountered. For the next part, it would be helpful to know the name of the column which contains all the table names. Now I could print out the name of just that one single column fairly easily, but it might be interesting to see what other column names have been returned by the table schema. So let's loop through the fields collection of the record set we've just opened. Let's head back to the VB editor, and I'll head up to the top of the subroutine first and declare a new variable. Let's call this one I as integer. I can then use that to count through the fields collection of the record set. So after I've copied all the data into the worksheet, I'm going to say for I equals 0 to rssheets.fields.count -1. The reason I'm going from 0 to 1 less than the number of items in the collection is that in the ActiveX Data Objects library, collections are based or have an index based from 0, unlike in Excel VBA where most collections are indexed from 1. So we'll go from 0 to 1 less than the count of fields and say next I. And then inside that loop, I'd like to reference a cell on row 2 in whichever column is referenced by the value of I plus 1. So to put that into code, let's say sheet1.cells. The row number will be row number 2, and the column number will be I plus 1. So the first time this loop goes around, we'll be referring to a cell in row 2, column 1, basically cell A2. I'll set the value of that cell to be equal to the name of the field. So I'll say rssheets.fields, and then in some round brackets, put in the value of I to return a reference to that specific field, and then write out its name. Okay, so having done that, we can just run the subroutine again. So again, I've still got my breakpoint here, so we'll only run this loop once and then stop, and I'll reset the procedure at that point. And if I check back on the worksheet now, I can see the names of all of the columns returned by that record set. Some of the columns are empty because they're not relevant for the type of data source we've connected to. You'd expect these columns to be filled in if we connect to, for example, a SQL Server database, for instance. Next, I'd like to be able to loop through the column of worksheet names that we've returned. And we have a few options for how we can do that. In the previous video, we used a do until loop to process the rows in that record set, moving to the next row each time until we hit the end of the file. Just for a bit of variety, what we'll do this time is grab that column of values and store them in an array. Then we can close down that record set and process the array separately. So to do that, let's head back into the Visual Basic Editor, and I'm going to start by declaring a new variable up at the top. So after dim I as integer, let's say something like dim sheet list as variant. The as variant part there is optional. I want to basically declare an empty array, and if I omit the as variant part, that's what I get anyway. But it's always nice to show your intentions when you're declaring variables in VBA, so I'll include the as variant there. Then I can scroll down to where we were just copying our data from the record set into the worksheet and our for next loop, and I'm actually going to just get rid of that section of code entirely. What we'll do instead is say, after we've opened up our record set, we'll say sheet list equals, and then we'll say rs_sheets.getRows. So again, a sensibly named method which tells you exactly what it's going to do. It's going to get rows from that record set. And the getRows method returns an array, a two-dimensional array, as you'll see shortly. I'm just going to open up some round brackets because I don't care about selecting absolutely everything from that record set. All I want to get is the table name field. So you can see we can specify how many rows we get, which row we start getting our rows from, and which fields we want to include. Well, I want to get all the rows, starting from the first row. The field I want to get, if I say fields equals, in some double quotes, I can say table_name, which is the name of the column we've just returned and seen in our worksheet. Okay, so having done that, once again, with the breakpoint there. Oh, one last thing I'm going to beg your pardon before I do this. Once we've extracted the results from that column, we can say rs_sheets.close, so we don't need to keep it open, and then we can say set rs_sheets equals nothing, and it will be recreated again the next time we go around the loop. And once we've connected to a different workbook, we'll get a different list of worksheets. So with that breakpoint still in place, I'm going to run the subroutine and it will pause after the first iteration of the loop, and might need to squint a little bit to see these in the locals window. If you don't have the locals window displayed, by the way, head to the view menu and choose locals window. But if you have already got it displayed, find your sheet list array. You can hopefully just about make out there on my screen that we've created a two-dimensional array. The first dimension contains one element numbered 0 to 0, and the second dimension contains 6 elements numbered 0 to 5. To see the contents of that array, we can expand the array and then expand the dimensions within it to see the individual values we've returned. So now that we've done that, we can work out how to loop through that array to extract each individual worksheet. So let's just stop running the procedure at that point and then move on to the next section. To loop through the list of names we have stored in that array, I'm going to make use of the integer variable that we declared earlier. So after closing down the record set and setting it to nothing, but before we close down the connection, I'm going to say for I equals, and we just saw in the locals window that the elements in the array are numbered from 0, so let's go from 0, and I want to go to the uppermost element in the second dimension of the array. So remember that the number of worksheets in each of these workbooks could be different. Let's say ubound. So this function returns the upper bound element number of any dimension of an array. We've got two things we need to pass in. First of all, the array containing the results we're interested in. So that's a sheet list, so I can reference the sheet list array. And then the number of the dimension containing the elements we want to calculate the upper bound of. Now, slightly confusingly, although the individual elements in the array are numbered from 0 by default, the dimensions of the array for the ubound function are numbered from 1. So we're interested in the second dimension, which means we need to put in the number 2. And if we then close the round brackets at that point, provide a couple of blank lines and then say next I, Inside that loop, I'm just going to debug.print the name of the worksheet, and I'd like to do that underneath each workbook name, indented by one tab space. So I'm going to say debug.print VB tab, and then concatenate that with sheet list, open some round brackets, and then I need to reference the element in the array whose value I want to return. Now remember, the sheet list array will contain 2 dimensions. The first dimension has a single element numbered 0. The second dimension is whichever number is currently held in the integer variable. So I'll say I. I can then close the round brackets. And again, still with that breakpoint in place, I'm just going to clear the contents of the immediate window quickly. So I'll run this up to the breakpoint first, and we should see we get the name of the Movies 2011 workbook written out with a list of the 6 worksheets held in that workbook. If I just press F5 or click the play button again to run the loop once more, we'll see the name of the next workbook with the list of worksheets contained in that one. And each time I hit the play button, it lists out the next workbook and the names of the worksheets held within it. So quite a lot of repetition here, of course. There's a limited number of month names to print out, but you should be able to see that the month names are different for each worksheet. Once we've gone through for each workbook, so once we've gone through all of the workbooks, the loop will stop. So we'll end up with a list of all the worksheets in the Movies 2016 workbook. So we have the main loop structure set up at this point. We're successfully looping through all of the worksheets in all of the workbooks in that folder. What we need to do now, of course, is work out how to extract the data from each worksheet. And basically, in order to do that, we're going to use another Recordset object and write an SQL Select statement to select all of the data from each sheet in turn. Now, we have a couple of choices for how we could make that work. One approach would be to write a select statement that selects all of the data from the first worksheet and then writes it out into the target workbook, and then closes that record set before moving on to the next worksheet, and then repeating the process. So we'd be opening and closing a record set once for each individual worksheet in each workbook. It's not the most efficient approach. A slightly better approach would be to construct a select statement, a query, that would select all of the information from this worksheet, and from this worksheet, and from this one, and so on and so on and so on, load all of that data into the record set in one go, and then write them all out into the target workbook in one go as well. So that means we need to open and close the record set once for each workbook that we encounter, rather than once for each worksheet in each workbook. So to make that work, I'm going to declare a variable which allows us to build up our SQL Select statement. So I'm going to head up to the top of the subroutine and declare a new variable. I'll call this one dim SQL string. And of course, the data type of that will be as string. Having done that, we can head back down to the loop, which is currently just writing out the names of each worksheet. And I'll add a couple of blank lines in there. And I'm going to set my SQL string variable to be equal to itself plus, or concatenated with, the next bit of text. So this is going to be the actual select statement itself. To make sure that I put together the values from each individual worksheet, we're going to use a Union All select. So I've opened up some double quotes, typed in a space and said Union All select. Then I need to reference the columns from the table. If I want all of the columns, I can use the asterisk character to represent all columns. From, and then I need to write in the name of the worksheet that I want to get my data from. That's going to get wrapped up in a set of square brackets. So just for the sake of argument, imagine that I was going to say it was from the May worksheet. In some square brackets, I'd have the name May followed by a $, and then close the square brackets and then close the double quotes. Now, of course, I want to replace that specific worksheet name with whatever name I'm currently looking at in that array. So I'm just going to take away the May and the $, and replace that with a double quote and an ampersand and a couple of spaces and another ampersand and a double quote. And then I'm just going to copy sheet list 0, I from that line and place it in between those two ampersands. So the name of the worksheet will be concatenated into the string. At that point, I can take away the debug.print statement altogether. I shan't need that any longer. Now I've got a small problem to solve before I move on to the next part. After I've finished looping to build up my string, I want to make sure that the very beginning of the entire string doesn't include Union All. I can't begin an entire select statement with Union All, I must begin with select. I can only place this after each worksheet that I'm selecting from. So to exclude that from the very beginning of the string, we can use a few different techniques. Here's what I'm going to go for. SQL string equals, then I'm going to use the mid function from VBA. So the mid function allows you to refer to a string, so that's going to be SQL string, and then say which character position you want to start from in that string. So there are 11 characters in that little phrase there, Union All, with the spaces either side. So I'd like to begin from the 12th character. So 12, and then there's an optional parameter for the length of the string you want to return. If we miss that out, it will just go all the way to the very end of the string and return all of the other characters. So I'll omit the length parameter, and that will give us our full query. I'm going to make sure that I print that out so I can see that it's returning the correct result for me. So I'm going to say debug.print SQL string. And then before we move on to the next iteration of our loop, be careful of this. Whenever you're building a string up inside a loop, remember that it's going to retain what was previously in it for the next iteration of the loop. I want to make sure that that SQL string is reset each time we go to a different workbook. So before we close down the connection, I'm going to say SQL string equals an empty string. Having done that, I'm just going to clear the contents of the immediate window. And then I am going to run the subroutine with the breakpoint still in place. So we'll see one single select statement printed out at this point. So selecting from the April worksheet, union to the December worksheet, union to the July worksheet, to the June worksheet, to the May and the November worksheet from the Movies 2011 workbook. If I hit the run button again, it goes on to the next workbook and creates a separate select statement, select from December, July, etc., etc. And at this point, I can just hit the run button a few more times and we'll see a separate select statement for each of our workbooks. Now that we've created our select statement, we can use that to populate a new record set. Let's head up to the top of the subroutine and declare a variable to hold a reference to that record set. So I'll say something like dim rsData as adodb.recordset. I then want to create a new instance of the Recordset class, and I'll do that just after I've created my new connection. So I'll say set rsData equals new adodb.recordset. To populate that record set, what we can then do is head back down into the loop, and just after we've printed out our SQL string, we can say rsData.open and then pass a value to two of its parameters. So the source parameter, first of all, I can just do this in one single line here. The source parameter is going to be our SQL string, and the active connection is going to be the only connection object we have available. It's called CN. So I just want to test that the record set is being opened successfully. So I'm just going to give myself a few blank lines, and then above SQL string equals an empty string, I'll say rsData.close. So a similar technique to the way we tested whether the connection object was successfully opening and closing earlier. So I've still got my breakpoint in place. If I run the subroutine at this point, it should pause on after the first iteration of the loop. So it looks as though it's successfully opened and closed our record set. If I wanted to check that there was data in there, of course, I could set a different breakpoint on rsData.close and then run the subroutine again. You'll see that it pauses on that line before it closes. And once again, you can have a quick check in the locals window about for the various properties of that record set. You can find out how many fields it contains, for example, and for each field you can see what the value of that field is. So it looks as though it's returning successfully the title of our films, as you can hopefully see in there. So at this point, I'm just going to disable my breakpoints. I'll click on each of these lines, and I can either click on the little circle next to the line or press the F9 key to clear the breakpoint. Hit the run button to get all the way through to the end. I didn't get any errors, so it looks as though that part's working quite nicely too. So the final part of the process is to write the data from the record set into our target worksheet. Just to explain how I'm going to do that, I'll head back to Excel first of all. I'll add a line of code in a moment that's going to clear the contents of the existing sheet first, but leave the column headings in place. And then to begin building up our list of all of the films, I'm going to take the approach of starting with the bottommost cell in column A, and then end Excel up from there to find the bottom of the current list, and then offset one cell further down from there to find the next available blank row. The reason I'm doing that is that if I start with a completely empty table and I went end Excel down to try to find the bottom of the list, I'll fall all the way to the bottom of the worksheet anyway, so it's safer to go from the bottom upwards to get this to work. So let's head back to the Visual Basic Editor first, and then let's add in the line of code that will clear the contents of the worksheet, except for the column headings. I'll do this just after the list of variables. I'll refer to the worksheet using its code name, sheet 1, so I can say sheet 1, if I can spell sheet, there we go, sheet 1 dot, range A1, and then I'm going to refer to the current region property. If you're not sure what current region is, you may well know this from earlier videos, but if I have cell A1 selected and I press Ctrl A on the keyboard, the range of cells that's selected there represents the current region. What I'd like to do then is offset that reference down by one row to exclude the column headings, and then clear everything from the cells that remain. So to make that work, let's head back to the VB editor and we can say current region dot offset 1, 0 dot clear. Then let's head back down into our loop, and to go from the very bottom cell in column A upwards, after we've opened up our record set, we can say sheet 1 dot range A 1,048,576. Oops, I just a slight typo there. 48,576 dot end Excel up dot offset 1, 0 dot copy from record set, and then reference the record set containing all of our data, RS data. Now this technique is fine providing you can guarantee you have that number of rows on the worksheet you're working with. If you're working in a legacy version of Excel, you may not have that number of rows available. So what we could do instead, well, we have a couple of choices, but we could exchange the range property for the cells property. And then the first thing we need to do in the cells property is specify the row number of the cell we want to reference. So we could do that by saying sheet 1 dot rows dot count. So no matter which type of workbook we're working in, we'll always find the maximum number of rows on the worksheet. And then the column index would just be the number 1 for column A. So that's a little safer if you're not sure which type of workbook you're working in. A final little bit of tidying up after we've finished with our loop and everything's been closed down, we're going to say sheet 1 dot range A1 dot current region, to reference that same block of cells, and then entire column dot autofit, and that will just make sure that all the columns become the correct width. I'm just going to comment out or even just delete my debug.print statements if you prefer, just to make sure that we don't fill up the immediate window with lots of information. I can clear the content of that. Those debug.print statements are unnecessary at this point. And then I can run my subroutine, and fairly rapidly I will have retrieved all of the data from every single worksheet in every single workbook in the My Files folder. So if your aim was to return all of the data from all of the workbooks in that folder, then job done. But if you wanted to play around with this a little bit, we can do some interesting things by modifying our select statement to include a where clause, and that would allow us to filter out which rows we weren't interested in by applying criteria to the query. So just as a brief example of the sorts of things we could do, let's say we wanted to return only the Oscar nominated films from this list. So we can reference the Oscar nominations column and check whether its value is greater than 0. To do that, we can head back to the Visual Basic Editor, and then we need to find the line which is constructing our SQL string. And I might just break this up across a couple of different lines here just to make it slightly easier to read. So after the equals operator, I'm going to type in a space underscore and then split that string onto 2 different lines. And then at the end of the existing line, I'll concatenate another space underscore, and then on the next line, open some double quotes and add the where clause to the query. I need to reference the name of a column first, and I'm going to put my column name in a set of square brackets. So the column name was Oscar Nominations. You don't always need to use square brackets to enclose your column names, but you do if the column name contains a space. So it's safer just to always include the square brackets, then it will always work. Then I can type in a greater than symbol and the number 0, close the double quotes, and then if I run the subroutine again, when I see my results this time, I've only got the Oscar-nominated films from that collection of files in that folder. We can take things a little further now. Let's say we wanted to limit the list even further to only the films in a particular genre. Let's say we wanted the animation genre for the sake of argument. So I can reference the genre column and then the text animation. If I head back to the Visual Basic Editor, I can extend my where clause by adding extra criteria. So I can say either and, or I can say or, and just like in VBA, the or operator will return true if either condition has been met. The and operator returns true only if both conditions have been met. So in this case, I wanted it to say and genre in square brackets equals, and then the name of the genre I'm interested in, the word animation, written in a set of single quotes within that string. Having done that, I can run the subroutine again, and I'll end up with an even shorter list of values. So there we go. And then just as one final additional thing we could do, we could test the title column. Let's say we wanted to find only those films whose titles ended with the number 2. So we can use wildcard characters to search text fields as well. So let's head back into the Visual Basic Editor, and after the animation criteria, I'll add another criterion and refer to the title column in some square brackets, then use the like operator. Just like in Excel VBA, you can use the like operator to compare strings using wildcard characters. The string needs to be enclosed in some single quotes, of course, and the wildcard character in SQL for any character isn't an asterisk, as you know from Excel VBA, it's the percentage symbol. So the percentage symbol represents any number of any characters, and then the number 2, so that basically says any film whose title begins with anything, but the final character is the number 2. So running the subroutine one more time, I can check back my results, and there we go, we've limited the list to only those films matching all 3 criteria. So there we go, that's how you get data from multiple worksheets in multiple workbooks without needing to open up any of those files. I'll drop a link in the video description so that you can download the files I've used for this video. Hope you found that one useful. Feel free to carry on asking questions, drop those in the comments below. Otherwise, thanks very much for watching. See you next time.